Alright, welcome back. In this part of the tutorial, we are going to talk about how to approach the transformation of the initial form by replacing parameters using functions and number sequences. In the first part of the video, we created this initial form. In the second part of the video, we talked about how we could modify a parameter to create this family of forms, all based on the initial form. In this part of the video, what we're going to do is we're going to recreate this method, recreate this family of functions, and but we're going to do it in a different way, where we appeal to the idea of a number sequence. So here's the basic idea. We're going to try to replace the a values just like we did before, from -4 to -2. But instead of creating a list as we did before, where we created directly the list A from -4 to -2, what we're going to do instead is we're going to think of that as a sequence of numbers, S0, S1, S2, where each of the entries is defined as a function of the index. That is, S sub 0 is a function of 0. S sub 1 is a function of 1. S sub 2 is a function of 2. So, in order to do this, what we're first going to do is create the list of integers. So, expression. We're going to first create a list of integers that represents the indices of the sequence. So let's define n to be from 0, 1, 2, up to 20. Alright, so this is saying that our sequence has indices 0 up to 20. And what we're going to do now is we're going to create a function that converts this index, 0, into S0. Okay, so in our case, what does that look like? So in our case, we want index 0 to correspond to entry -4, and index 20 to correspond to the parameter value -2. So because this is a line, what we can do is we can say, all right, we need a line, a function, s of x, to be a linear function of the input. And what we want is we want a function that has slope. Well, what's the slope? The slope, because the rise is -2 minus -4, which is 2, over 20 bits is 20 minus 0. That means the slope of this function should be 1 over 10. And because we chose the initial index to be 0, that's what the y-intercept is. So what this is saying is s of x is equal to -4 plus x over 10. Alright, and so what that means is the list s of 0, s of 1, ... s of n is the same as the list that we created above. And we can see that. Let's quickly look at what that looks like. If we type in n comma s of n, and we plot these points, what is this saying? It's saying that when we plug in s equals 0, let me label these points. When we plug in n equals 0, we get s of 0 is -4. When we plug in 1, s sub 1 is going to be equal to -3.9 because we've increased by 0.1. That's this here. When we plug in n equals 2, we get -4 plus 2 over 10, so that's -3.8. And so if we continue and we go to the 20th, the point corresponding to s sub 20, we're going to end up with -2, just like we wanted. So what that means is that the list s of n, because n is a list and s is a function, s of n is also a list. And just like we did before, what we do is we copy our function here. We paste it. And instead of putting a here, what we want to do is we want to put s of n. Right, and so if we do this, we go back to where we were, zoom out, move over, we get the exact same picture that we had before. Just now this s of n is defined is a function. S is a function of the index. All right, and why go through all this trouble just to recreate something that we could have done otherwise? So there's two reasons. The first reason is because in the next video what we're going to do is we're going to use this to modify multiple transformations at the same time. And the other reason for this is because it allows us to use a more interesting function for s of n. So right now these are steps where each of the steps has step size 0.1. But what if we wanted there to be more lines at the bottom and at the top and fewer in the middle? Well, we can do that. If we create a new function, so instead of s of x, I'm going to create a function where let's put up this s of x and this t of x. What if instead of creating a function that's a line, we create a function that's a curve? All right, so this is a curve. I'm using the cosine function. And when I do this, when I do this and I plug that in for our function, so instead of using s of x, I'm creating t of x. So I've replaced s of n by t of n. And if I take out all these other bits, you can see that this function that I created now has a whole bunch more lines at the top and at the bottom, and it's more sparse in the middle. So it allows you to add more dynamics to the transformations that you are creating. So that's enough for now. Tune in to the next video where we'll talk about applying multiple transformations at the same time. Thanks. Bye.